Let's look at an example. This example, the data come from a study on emotional labor. The researchers would like to identify the relationship between level 1 data, that is the diary data only, to investigate the relationship between emotional regulation strategies, that is the emotional labor, and exhaustion after the interaction. To examine this research question, first we have to consider whether the between variance is significant or not, whether the individual differences is significant or not. If it is not, and we are assuming that the data coming from different individuals are very similar, in this situation, the normal correlation or multiple regression analysis could be used. However, if we consider that the level 2, the individual level differences is substantial, we have to conduct the multi-level analysis. Sometimes we are not interested to find the level 2 differences. For example, for a cross-sectional studies, we collect the data in different organizations. However, we are not interested to see how this organizational effect will become a significant factor in affecting the individuals. In such a case, we do not need to perform the multi-level analysis. However, sometimes we are interested to see the level 2 differences to see how the organization factor will affecting the dependent variable. In such a case, we have to perform the multi-level analysis. In our example, if there would be no variance at the individual level, the person level, it means that all the person behave in a very similar way. We can ignore the diary data are coming from different people, and so we can only perform the standardized, the normal standard regression, the SPSS. We do not need to perform the mixed model, the multi-level analysis. This is the structure of the equations for the regression analysis. The first equation is for the standard regression equation. The second one is the example of the level 1 effects at the multi-level. The only difference is for the multi-level equation, they have J. J means the level 2, the person effects. They also take into consideration of the person effects. The exhaustion of the interaction is the dependent variable equals to the intercept plus the coefficient of the surface acting and also the error term. The only difference, as I said, is the including J, that is the person level, the level 2 effects also considered in the equations. From this figure, as you can see that for the standard regression equation, beta 0 is the intercept level and beta 1 is the slope. The slope of the x1, the slope of the independent variable and plus error term. And so here is the figure for the standard regression equation. If there is a substantial individual differences, the level 2 differences, we have to perform the multi-level regression equation. From this figure, as you can see that different regression line, different regression coefficient for every person. Every person will have their own very different intercept and slope. And you may have a question that, is there a level 2 variable that have an impact on the slope? So that is the moderation effects. And one of the example is, if job control is low, then surface acting has a stronger impact on exhaustion. For this research questions, job control becomes the moderator. So we would like to see whether individual differences in terms of job control will make a difference in affecting the relationship between surface acting and exhaustion. Because of that, and we are assuming that people are different in terms of the job control, that's why we have to perform multi-level regression analysis. As we said earlier, the only difference between the multi-level regression equations at level 1 and the standard regression equations is they also consider the Poisson effects, the J index, represented as the Poisson effects. And here, the beta 0 J refers to the regression's intercept, in representing that different persons will have their own intercept level. B1J, Xij also refers to the individual slope. And finally, residual, the Rij is the error term. And as you can see that I refers to the index for the level 1 unit. In our case, is the diary date, the diary data. And J refers to the Poisson level. In our case, is the Poisson level variable, that is the job control. If it is presented in the figure, as you can see that every person has a specific intercept, and every person has a specific slope. When we combine them together, as you can see, every person has a specific intercept and had a specific slope. This is the combination of equation at level 1 and level 2. It sounds quite complicated, but in the next slide, we will use figures to show you the logic behind. Let's use an example to illustrate. If we are interested to investigate the relationship between quality of conflict solutions and the satisfaction with interaction. And here is the data from person A and person B. In this situation, indeed, we did not care too much about the individual differences. We just combine them together and find a regression line. And this is the normal regression analysis. However, in the reality, as you can see that if X refers to the data from person A and the square one is the data from person B, if we consider about they are the two very different individuals, we are using the multi-level analysis, we can consider both the within individual variance as well as the between individual variance. That is, we consider that they are the two different individuals. And then from this, you can see that the data from the person A, they will have a regression line, the green one. And so you can see that the data is the every observation of the data will got some variation with the regression line to see how much differences will be vary and over time. For data from person B is the squared one, and you can also test the within individual variance, and so to see how variation of the data coming from this individual. They are not making a comparison between person A and person B. Instead of, they are just making the comparison with themselves, everyday data, to see whether they have much variation or not. If we are doing a multi-level analysis, we would like to see if we combine the data of person A and person B, and well, to build a red line is the combination between these two persons, and then we are interested to see how the data from person A will be different from the data from person B, that is between individual variation. We are going to see how these two persons could be different from the mean level. This is the between individual variance. To analyze the diary data, the first step is to perform the percentage of the revealed individual variance, because we want to know whether it is appropriate to utilize revealed person modeling for data analysis. If we could find that there is no variation, if the employees every day they perform the same, and it is not necessary to perform the revealed individual, the diary studies. As you can see that the total sum of the square equals to the within group sum of square plus between group sum of square. The idea is that we have to consider both the within group variation as well as the between group variation to see whether they have some variation within themselves as well as the variation with other persons. So altogether, that is the total sum of squares. By equations, the total variance equals to the total sum of square divided by sample size. If we are calculating the within individual variance to see whether they have some differences on the daily basis, on the diary design, and we have to do this calculation. The within group sum of square divided by sample size. If we would like to see, is there any variation between individuals, how different they are with other individuals? We have to do this calculation. Between group sum of square divided by sample size. Please note that the sample size refers to the measured daily responses of the datasets. It does not represent the number of the participants. Instead of, it is the measured daily response of the datasets. How many responses, observation that can be collected. And here is an example of performing SPSS mixed model, the multi-level analysis. We are interested to see the relationship between quality of conflict solution and satisfaction with interaction at a daily basis. So we are collecting the data at a diary design. To perform the mixed model in SPSS, we have to investigate to what extent and whether the within person variation exists in the datasets. And so to see whether we should investigate these research questions appropriately in the daily basis. The first step is we open the datasets in the SPSS software, that is the Emotion Date Level 99 combined datasets. We click on Analyze, Compare Means, and One-Way ANOVA. Next, because we would like to see whether the variable is appropriate to analyze on the daily basis, we would like to see whether they have the within person's variation. So we put all the key variables under the dependent list box. They are conflict as well as satisfaction with interpersonal relationship. And we also put the new ID variable under the factor box because we would like to see whether the data coming from each individual will have the within person variation. That's why we put this variable as the factor and to see whether within persons variation exists. The next step on the right-hand side, we click on Option, and then we click on Descriptive Homogeneity of Variance Test, the Brown fork size, and also the wage. And then we click on Continue. From the ANOVA table, you can see both the between group and within group sum of squares. We have to use the number to calculate the within individual as well as between individual variance. For the within individual variance, as you can see that the equation is within group sum of square divided by sample size. That is 621 something divided by 420. Please note that we have 49 participants, but we are not divided by 49. Instead of, because we are collecting 420 observations, the total observation. And that's why we have to use 420 observations as to divide it by this number. And we got 1.48. For the between group individual variance, the equation is between group sum square divided by sample size. Again, it's about the observation. So that is 215 something divided by 420. That is 0.51. Please note that the observation 420 could be coming from the number of participants times how many times of the observation per day times how many days of the data collected. So altogether in this sample is 420. For the variable of the conflict solution, we find that the within individual variance is 1.48 and the between individual variance is 0.51. And the next step is we have to calculate the percentage of variance within individuals. And the equation is the within individual variance divided by blanket within individual variance plus between individual variance. So the equation for this example is 1.48 divided by blanket 1.48 plus 0.51. So we find it. There is a 74.37%. That is the percentage of variance within individual in terms of conflict solution. For the variable of satisfaction with interaction, we are using the same table, the ANOVA table. The within individual variance, we also look from the table, the index is 482.845 divided by 420. So that is 1.15. And the between individual variance is coming from the between group sum of square divided by the sample size, and we find that is 144.095 divided by 420, and we got 0.34. And the next step is the percentage of variance within individual was calculated as the within individual variance divided by blanket within individual variance plus between individual variance. And so that is altogether is 77.18%. The within variance percentage of solutions and satisfaction are 74.37% and 77.18% respectively. It shows that the variation is quite substantial at the data level for these two variables. Therefore, we can conclude that it is appropriate to utilize within path modeling for data analysis because we find that even in the within the level, and we still can see some variations across different time, across daily level. That's why we are assuming that it is appropriate we can conclude that this is appropriate to utilize the within path modeling for the data analysis. Now, I hope you can work on this exercise on your own to compute the percentage of within individual variance across three variables, including surface acting, anticipative deep acting, and also situational deep acting. Please use the data file emotion date level 99 combined doc.sav file to work on this analysis, the within individual variance analysis. Let me give you some hints. First, you have to work on the ANOVA analysis. From the ANOVA table, you will see the index of within group as well as the between group sum of square. And remember that the sample size is 420. That is the observation, the total observation this studies. After that, you have to calculate the percentage of variance within individuals. After all, please watch the next videos and we will have discussion on the answers.